All right, folks, this is your topic 3 test review. Okay. Okay, so number 1, all we're doing, we're looking at this line and we're writing the equation of the line. Now the equation of the line will be in the form of y equals mx plus b, right? I think it's probably easiest to find the b first. That's your y-intercept. That's where the line crosses the y-axis. So this is at 0, -2. So I'm just going to write that out there, right? Okay. You could say plus -2, but it's probably a little more correct to say -2 because you don't want two symbols when one will do. Now we've got to figure out our m value or our slope. So it's going to be this here. Typically it's going to be a fraction. So you want to find 2 points that are on the line and on the grid. Now 0, -2, or the y-intercept is generally a good point to start with because it will be on the line. I got here, I look here, this is not on a corner of the grid, neither is this, but this one is on the line and it is on the corner of the grid. So now that I have my 2 points, I can figure out the slope. I'm going to do rise over run. Okay, and basically you just count how many boxes you went up or down, right? Since we're going up, this is going to be +2 and then over 3, right? So your slope is rise over run. So rise is right here, run is right here. So it's 2 over 3. So that's your equation of the line, y equals 2/3 x minus 2. Okay. So what kind of association does a scatter plot show? Think about the following vocabulary. So this one is positive because it's increasing. It's going up as you look from left to right. Okay. This one, as you look from left to right, it is going down. So it's decreasing. So it is negative. Okay. It is linear because you could like draw a line through the middle of that data. I would say it's probably pretty strong. So we would say this has a positive, strong, linear association. Okay. Student was asked to place the number square root of 8 on the number line below. Student claimed, oh shoot, hold on here, give me a sec. I'm gonna have to pause here, my bad. Back to it, guys. We're actually good. A slight typo. This should be square root of 11. Okay, so we're placing square root of 11 on this number line right here. Student claimed that square root of 11 is 5.5 because 5.5 times 2 is 11, so it goes between 5 and 6 right here. We're going to talk about why that is incorrect. Put it where it's supposed to be, and then explain the reasoning you choose. Explain the reasoning you use to choose your location. Let me actually adjust this while I'm thinking about it. This is number 3 right here. This should be 11, and there you go. Okay. Okay, student is incorrect because you don't just divide it in 2. It's not just like multiplication and division, right? You got to figure out the number that multiplies up to 11 by itself. So it's not 5.5 times 2. It's going to be the same number multiplied by itself. And so we would say how you figure out a square root. A square root is not dividing it by 2. You have to find the number multiplied by itself that gets you to 11. Okay, so provide the correct location. So, so if I have the square root of 11, I know if I look at my square root thing, I know it's in between 9 and 16, which means it's in between 3 and 4. Now it is 2 away from 9, and it is 5 away from 16, so that means it's closer to 3. So I don't know, like a 3.3 or something right here. So that's the second bullet point. So 3.3 would be here, right? The correct location is between 3 and 4. And then the last one right here, explain the reasoning you choose. Well, yeah, so basically we just kind of just explain this, right? The square root of 11 is between 3 and 4, and it's closer to 3. So, well, I guess that's, I mean, the square root of 11 is between 3 and 4. That's the explanation right there. So that's why it's between 3 and 4. I don't know, it's kind of using a little bit of circular reasoning, but I mean, we figured it out right here. The correct location is between 3 and 4, my bad. That's why it's between 3 and 4. Okay, good to go. So which ratio represents the slope of this line? This goes back to figuring out the slope of a line, right? You figure out your rise and your run, right? So this number right here is going to go on the top of the fraction. This number right here is going to go on the bottom of the fraction. But you might say, oh, well, Mr. Wishart, there's no numbers right here. But you still know that this is the rise and this is the run. So the ratio would be A over B. Okay. Data was collected on orange juice production. The data is shown on the graph below. Student 1 claimed that an equation in the form of yx mx plus b would best model the data. Student claimed that an equation in the form of yx would best model the data. So this is number 5. Explain why student 2 is correct, basically saying that y equals mx is the way to go. We would say why. He would say, let's actually start with answering the question. Student 2 is correct. Because, okay, you would not have a value. Let's say I don't like that actually. Shoot, losing my pencil. So student 2 is correct because this situation. Let's say the y-intercept. There you go. Because I like this. It's not proportional. It is proportional. Good Lord, Wishart, can't talk here. It's proportional. So the y-intercept would be 0 because without any oranges, you would not have any juice. Okay. All right. Provide an equation that models the data. So it's going to be in the form of y equals mx. We know that. Okay, so we basically just have to figure out our slope, right? So if I kind of draw a line through here, and it's going to be like this. We have a point right there, and then let's figure out something that's going to give us that, right? If I kind of look like that point, it's like this is kind of like a rough drawing of it, but I like that right there. So our slope would be going up 16 and then right 20, right? So our rise is 16 and our run is 20. So just like we did in the problem number 1, right? Our slope is going to be 16 over 20. We simplify. by dividing the top and the bottom by 4. So we end up with y equals 4/5 x. So I got that, I got that. If let's explain the step or steps used to write your equation. We'd say like, I found the slope. I found 2 points on the graph and used them to get or find, generate rise over run, which is my slope, and then put them into the equation, and then put that into the equation. Into y equals mx. It's probably good. Okay, so that's that right there. So 1, 2, 3. Explain the meaning of slope in your equation. Well, the meaning of slope is just, so if we look at this, right, it's 4/5. So it's 4 gallons of orange juice per 5 pounds of oranges. So the meaning of slope is for, let's start with the x value because that's the dependent or the independent variable. 5 pounds of oranges, you get 4 gallons of juice. Determine approximately the number of gallons of juice you would expect from 135 pounds of oranges. So our equation is y equals 4/5 x. We have an x value of 135, so basically it goes right here. So it's y equals 4/5 times 135. And this is actually going to be 2 bullet points right here. Well, actually, we'll just talk about it in a minute. So we're going to get 4 times 35 on top, or 4 times 135, and we'll divide by 5. Okay. So, like the glare on this is terrible. 4 times 135 gets us to 540. And then we'll divide that by 5, the answer by 5, and we'll get 108. So y equals 108 gallons of juice. Right, and then my steps are above. Because it says or show, right? So you don't actually have to write it out. Okay. This one said explain, so you had to like write it out right here. But this one says show, so you can just show the math for it. Okay. Okay. 2 lines are represented below. We got 6x plus 2, and then we got function b right here in this graph. So this is talking about rate of change and then initial value. So rate of change right here, and then initial value. You could also call this the slope and the y-intercept. Okay, so we got to figure out the slope and the y-intercept here. So we figure out that these are going up by 3s. We figure out these are going up by 4s. So when you have a table like this, the y values are your rise, the x values are your run, so it's going to be 3/4. So the equation for this is going to be y equals 3/4x here. Okay, and the y-intercept will just reverse it till we get to 0. So we would basically, rather than adding 4 to reverse it, we would subtract 4 to get to 0, and we subtract that to get to 17. So that's our y-intercept right there. So which one has a greater rate of change? Well, this one has a 6 for rate of change, and which function has a greater initial value? This one has a 17. So we'd say function A has a greater rate of change, while function B has a greater initial value. Okay, The equation 2.3x plus 5.7 represents how quickly a plant grows, where y is the height in inches and x is the amount of sunlight it gets per day. So how many inches does the plant grow per hour of sunlight? The amount of sunlight per day. So it's like whatever, 2.3. I mean, that's a really fast-growing plant. But anyway, that's what's associated, since it's saying grow per hour of sunlight, so that's our x value. So whatever number is close to the x value, that's kind of like what it's talking about. And how tall was the plant when we started measuring it? That's our initial value, so 5.7 inches. Okay. Solve this linear equation. We're going to subtract 3x over here. To get the x's on the left and the numbers on the right, negative 5 minus 3 is negative 8. Please use the number line for that. If that troubles you. Now we're going to add 8 because that's what cancels that out right there. We're going to add that there to get to 24. Now we have multiplication happening here, so you do the inverse or the opposite. We divide by negative 8. We have a negative number because we have a positive divided by a negative, and that's going to get us to 3. A worker charges customers an hourly rate and an additional fixed fee as shown in the table below. How much does a worker charge per hour? So we got to figure out the difference here, and it's going to be our slope, right? So the easiest way to do it is probably just to subtract, right? So 370 minus 220 is 150. And then 520, just to double check, minus 520 minus 370 is also 150. And these are going up by 3s. So the idea here is that our slope is our rise over our run. So it's the change in y, 150, divided by the change in x, 3. So it's not $150 per hour, it's $150 per 3 hours. So it's asking per hour, so it's just per 1 hour, so we do that division. So we'd say $50. So the worker charges $50 per hour. Okay, random sampling of students was surveyed. The data is shown below. What is the total number of students that like soccer? So like soccer is going to be the column right here. So I just take these two and I add them together. And I do believe that is 35. So we'd say 35 students like soccer. What are the solutions to these equations? Well, if we look at our perfect squares poster, we get 36 is 6. We also know that 6 times 6 is 36. So we get x equals 6. However, it's also negative 6, right? Because negative 6 times a negative 6 gives you a positive 36. However, when we switch from being a square root to a cube root, so since we're multiplying 3 things together instead of 2 things, we can't have 2 answers to this. We'll only have 1. And in this case, it's negative 6 because we look at our cube root table and get that negative 6. A survey was given to a sample of 70 randomly selected students. The results of the survey are shown in the table below. Fill out the table. So let's see, that's going to be 17. 13 plus 17 is 30. 40 minus 21 is 19. 17 plus 21 is 38. Check. 13 plus 19 is 32. Right? Yes, 32 plus 38 is 70. Okay. Is it likely that a student that likes music is a girl? So we're looking at this column right here. And we compare 21 to 17. There are more girls that like boys than music. So yes, 21 girls versus 17 boys like music. So if you basically if you were looking at just the students who liked music, more of them are girls than boys. Is it true that less than 50% of boys like drama? So if you just look at the boys right here, we've got 13 out of 17, 13 compared to 17, or 13 divided by 30. If we wanted to be real sure, we would take 13 and we would divide by 30, and that is less than 50%. So you'd say yes, 43% of boys like drama. Thank you.